Okay, hi everyone. Uh, I was just had a little trouble parking. Uh, oh, I still have some water left. That's good. Okay, so there's nobody presenting today, but um, if you want, if you could, just whenever there's, up to two people a day. If you present, you present like would be the time you present at the beginning of class, okay? Or if we have a break, right after the break. Um, okay, so today, let me just briefly go over, first of all, let me take attendance, and then let me see if I can find the attendance. And attendance, here we are. Okay, so the people can hear me on, oh, I'm sorry. Sorry. Um, Not working? Hold on. Here we go. It should be on soon. Uh, Okay, great. So, I just want to take attendance. Muhammad Ali, are you just the people I missed on Tuesday? So, Muhammad Ali, are you here? MD Azad, don't be bashful if you see your name. Anybody at home see their name? Ashley, uh, Daniel Fernandez. Okay, yay. Okay, and then we have Sayantan Saha. No. And we have Nagin Saira, and we have Ahmad Shah, okay, and Faraj Shah, and just be careful. I hope there's other Shah. I don't when I grade. I don't want to give the wrong Shah. Yeah, I get very nervous whenever I have two people with the same last name because usually when I grade, I don't have duplicates of last names. So, but I grade. I have to be very careful. I make sure I grade the right person. So. Uh, right, right. Yeah, but like sometimes I get very and whenever I see the same last name, then in the back of my mind say, okay, when you mark, get it straight. Okay. I once had, I think, was it two brothers or yeah, two relatives. I forgot. I think maybe two brothers or two sisters. I definitely had two sisters with the same last name. I think they were twins, actually. But yeah, once yeah. Anyhow, uh, okay. Anyhow, one more person, Zahid, Nazat, Zahid, here, not here. Okay, so that ends our attendance. Please, could someone on Zoom say something? I just want to make sure we could hear you. Would you mind? Actually, we should be able to hear you. If we don't, let me just see. Could someone try to say something? Let me just see the uh, audio source. Oh yeah,
Yes,
I
we
can hear
can
you.
hear
Yeah.
you.
I'm sorry. That was great. Yeah, I heard you.
We can hear you.
You what?
We can hear you.
Yeah, no, I want to make sure I can hear you. So, because I was taking attendance, I want to make sure somebody
Uh, Hello,
here.
Professor.
I'm sorry.
Yeah, I wanted to for my attendance. The first person there,
Which is your name?
Muhammad,
What line? What line number?
uh, ALI one, number one.
Oh, the first line.
Yeah,
This is you?
yeah, that's me.
Okay, yeah. Thank
Yeah,
you.
I wrote in chat. I don't think you saw it.
I can't. Was I think I know. I think the volume here is pretty good. Just you. Okay, but I marked you here. Okay, is that good?
Yeah, I wrote in the chat. I don't know if you can hear me.
Okay.
Yeah.
Okay. So for those who missed the first class, we went through the syllabus, and I guess the most important thing to know right now is where everything is. So everybody knows that, should know that's all on this. Everybody should have gotten an email. If not, ask one of your classmates or me for the link, and there's a Google Drive over here where I put everything after class. So for example, after Tuesday's class, I have a class one folder, and over here I put the lecture documents and also video from it, recording, which I don't guarantee, so don't hold me. But I do, whatever, if something doesn't, usually if something works okay, I get a good recording, and then sometimes there's a glitch somewhere and I don't get a good recording, so, but that's pretty rare. So, so far, okay, so so anyhow, we spoke about was just look around the folders, um, specifically the schedule folder. Then there's also the um, there's also the presentation folder where everybody has um, the default. Um, I made like a default presentations where oh, some people already entered this February. Oh, okay, wow. Oh, some people are already thinking about doing it, and I highly recommend. And okay, so so look at this, and you should be able to modify this document. Pretty sure I made it. Obviously, because people added their dates in there. And if you don't like the topic, just email me and you could change it. Okay, but first email me. So now it's over here. There's um, there's what I suggested, but it's just because, people, if we really have something else you're interested in that has to do with software engineering or software development, feel free to send me an email and switch it. Okay? These are I just gave people because, to give them an idea. But,
So
but
if I just pick a topic like that, quantum computing something, is it?
say again?
So let's say if I pick a topic like quantum computing or like something like that, I mean, is it acceptable or not?
What type of computing?
Quantum computing. Like,
Quantum? Sure, that's great. Yeah.
do you really want like some coding in it as well?
No, so the way it works is, let's see if someone made an upload. So we have another folder called Upload Your Presentations, and so far it's empty. But like typically it would be a PowerPoint, and also the instructions over here give basically we just want you to get straight to the topic, and as this document over here says, it tells you like we don't want to hear a ChatGPT presentation. We want to hear your presentation, how you understand it, right? Because we could all Google, we all have ChatGPT, whatever it is. We want to hear your take on it, your opinion of it, of whatever your assignment is. Okay, so it has to be your own words, meaning that natural, right? They show us, convince the audience you understand what you're presenting. That's, I guess, the best way to say it, right? It's like the main, and also no more than 5 minutes. So it's get in and get out. Don't spend a lot of time saying, well, the background of computers were invented during World War II by whatever, blah, blah, blah. And then finally, last minute, now, you go on, do not do that, please. Not that I'm going to stop you, but if you notice in Congress, there was a 5 minute rule. So in Congress, whenever they have a hearing, it's always 5 minutes a person. So that's considered to be enough for a person to speak and present their idea. So let's try. So obviously 5 minutes is a good measure.
So if
Yeah.
you're reading a person, should we do that on over there?
Oh, yes. So the way it works is you upload some type of document to this folder over here, which you have permission. You should have permission to. Let me know if you don't. If you don't, you can always email it to me and I'll upload it. And then you stand over here in person. Oh, yeah. So there's 3 times you have to be in person. Number one, for presentation. Number two, one and two and three is for midterm and final, right? Otherwise, you could, do your own thing. And then the projects, which we can get to after the midterms, is going to be where you do a coding project. And that is going to be over Zoom because since there's hopefully 35 students, right? So each one's going to take, yeah, I don't expect everybody to come to class and wait their turn, you know, so there's no point in that. So I have, if you look at the schedule, I actually, uh, based on my experience doing this stuff, that right now it's scheduled um, for the projects. It's going to be um, it's going to be on April 21st. So over here, you notice I said it's between 7 and 12 p.m. It should say 12 a.m., right? It's 12 a.m. or 11:59 p.m. So let's keep it positive. So basically, you could enter any time between we'll have a sign up thing for that when we get up to that. And then we'll explain everything after the midterm, okay? Because until the midterm, the project presentation is going to be on a design pattern. We're not covering anything yet. So we haven't even done one design pattern. So we can't really get into it until after the midterm, okay? So, but, okay, so that's that. Okay, so, oh, here we are, the 29th, yay. Wow, time is flying. Okay, okay, so that's that. And, oh, right, so again, you go over here and when you find a day for your presentation and then you enter it here, just so we only have, because you can only have maximum 2 people a day. You don't have to necessarily, yeah, nothing. You don't necessarily have to have your a date there, but like today, like there's no one here, anybody can present. I don't care, you know. But we don't want to have like 5 people in one day, you know. So because of that, I just clicked the wrong thing. So we have um, where is this? I'm doing the wrong thing. Folder, wrong folder. Um, Sorry about that. Um, yeah, so what you do is you upload over here, you mark under here, yeah, you put your presentation time, okay? And so I just want to finish off what we started on Tuesday. And let me just see what, by the way, if yes, I can hear you. I'm here, first person. Yeah, great. Okay. So in general, I don't look at the chat for Zoom. So if you have something to say, just say it. Okay. Um, I'm not, I'm not what's the word? I can't do a lot of different, I can't handle a lot of different things at once. I just like, it gets me too distracted. Okay. So today let's finish up chapter 1 and then we're going to move on to object-oriented principles. So, um, here we are. Okay, class 1. Now, oh, wrong document. Sorry about that. Here we are. Okay, so we went through this. We went through the most important part. Just to review what we did on Tuesday is the steps for a project. So we said it's normally if you would just Google it, right? Most websites will say there's requirement. Well, the big ones are requirements, meaning these are like like I'm not well I mean we're doing 8 steps, but if you Google it, the main ones you'll always see are going to be requirements, meaning that you you find out what the customer wants. And then remember difference between requirements and specification? Anybody remember the difference? A specification is a requirement, just it's like from a different perspective, right? Requirement is from the viewpoint of the user, and specification is the viewpoint of the what?
Designer. From the viewpoint of the developer or the one who.
Oh, yeah, right. And there's like an example I gave. I like the example like if you go to a doctor and you tell the doctor that my stomach hurts, that's my way of explaining it. But the doctor is going to write down, something, upper pain, whatever, maybe a fancy word for pain. Patient mentioned that there's something in the upper quadrant of their blah blah blah. Right. So they would be more specific because I mean that would be because that's how they view it, right? They're looking at it from a different perspective, right? They're looking at it from, they have a different viewpoint than the user, than the patient. The patient just says my stomach hurts, and the doctors, is trying to fix it. They're looking at it from a, well, let's see exactly what do I have to do, So two different ways of looking at the same thing. Right. So so this is always going to be important, right? That you have to find out before you run a program, you have to know what it is exactly and it sounds like a simple thing, but it's not because um, because people like to jump into stuff without really thinking about exactly what it is that, in other words, like you see it all the time, right? People hire a designer, right? Or, to do something. And then when they see it, they say, that's not what I want. Could you, whatever. So a requirements is actually a important thing to get down before you do it because you don't want later on to, the client tells you, that's not what I asked for. I said, but you said this. The person said, well, but I meant this, So requirements are actually a very important part of programming. It's like you don't get that in college because in college you just get, write a project that is, for that semester. So you're not dealing with huge projects in college, right? Um, I'm sorry, excuse me. I don't think I have a cold. It's just I don't know. Just the cold. It's a little cold here also. Anyhow, so there's requirements, which we said is very important. And then I mentioned also, if you remember on Tuesday, that like if you go for a job interview, you should also not just like answer the question, like you should think about what they're asking and you should ask them questions. So if someone says, write a program write a method that does something, you say, well, what's the limit? Like, what's the max amount that it should handle? Is could it be, do you want it to run be able to run in parallel on multiple machines? Just think of things that make, I'm not saying make up things, but think about it. Show the person who is interviewing you that you think about a problem. You don't just run in and start coding and then later on say, then find out if they have if that's what you think is what they think, right? You try to show that there's some, depth to the way you do things, not just jumping into things. Like I'm the type of person who jumps into things. Yeah, I hear something and I'll just, yeah. For me, it's a very difficult to sit back and say, okay, what would happen in this situation? What do you want to happen over here? But it's important because if you don't do it, then you just run into problems later on. So requirements is important. So this will always be part of a project. You'll always see coding, right? That's obviously there, right? And you always are going to see testing, right? Those three things are always, wherever any website, anywhere you look, right? But I added more steps to it. But like these are the ones you'll always see. Um, this one, requirements, coding. Now, when you see the slashes, I just wrote like when you read the book, or if you read the book, you'll see that they like using different words for the same thing. So I just like threw in all the words that mean the same thing. Like I never knew the implementation meant the program. Right. So I remember when I went to college here. I asked um, one of the professors here, Dr. Waxman, he's still here. I said, said, it says in this job description, they're looking for somebody that does this. Is that a little different than programming? He said, no, it's all programming. It sounds different, but yeah. Yeah, so these are all the different, you can implement, develop, program, code. It's all this, those words all mean the same thing. Okay. And then there's always testing. So these are the big three, right? And then I added a couple more things um, based on the book or based on what I saw. So I added feasibility, which means that since programming is a very expensive um, endeavor, right? And anything custom is expensive, right? Anytime you're hiring people to do something specific, not off the shelf, it's always going to be expensive. So you have to know whether the person wants to pay for that, right? Um, but just look at anything in the military. Whenever they build something, it's always so sometimes it's because it's just, people take advantage, but very often it's just because of the changes that are made. Or problems are encountered while developing anything new is always going to, is always going to cost more and take more time than you think it will, right? So look at the self-driving Tesla. It's still not there, right? But when was it supposed to be? Like 5 years ago? I don't know when, but you see, it's a lot of new things are a lot more difficult than. In fact, I was just heard like it was yesterday, I think, that there's like a Tesla has like a come to me feature where like if they'll drive up and pick you up. You heard of that?
I have just, it's called Summon. So that feature is called Summon.
It's called what?
Summon.
Summons?
Yeah, so let's say if you're in a parking area or like it's not like Main Street, like main area, you can just summon the car to you. So you put your address, so the car will come to you.
Really?
Yeah. It's
And it's allowed, it's legal in New York City?
it has to be like local streets. It should be like like big streets, but it definitely works in parking lots or I don't know, like if it's like an area, I don't know, like in Long Island, almost every neighborhood it works there. I tried it.
Wow. That's so cool. Okay, so someone gave an example where someone summoned the car for them and they were in the airport and the car went right into an airplane because it was trained about streets and objects on streets. It never was trained about airplanes, so it went right. It's hard to understand how it could go straight into an airplane, but it did. So
So that's have a feature that you're pressing the button, like one of the features of the sound in the neck. So let's say if you want to let the car go straight, so you push the button on your phone, so it goes straight. It ignores any object comes in front of it. That's like one of the features. So
that's a feature.
yeah, just goes like as if you're drawing it. It will give you a warning sign like, oh, there's an object, but like if you keep pushing that button, so it will keep going. Yeah.
Oh, wow. Whatever. So I guess that's what happened. I don't know. Like it's hard to understand how a car went right into an airplane. So um, yeah. So I mean, but it wouldn't do that into a wall, would it? If you say go straight, it won't go into a wall.
If you keep pushing the button, it will.
It'll go to a
Yeah,
wall?
give you warning, but if you actually like put your location, like let's say it works very good here inside, like let's say my car is parked in parking lot, and I just put my location here, like this, you're out, like somewhere here, like right outside the building, so the car will come to me. But if I just say that, oh, go straight, go back, so I keep push the button like to go straight or backward or front, so that will keep going that direction. But they keep me warning, like, okay, there's an object in front of you, just like you're sitting there and you're driving it, yeah.
Uh-huh.
Yeah.
Wow. Okay. Oh, I wonder how would it handle over here because the gate is closed. Would it know that the gate was closed? I don't know.
Yeah, I mean, like, outside of the building where the car was driving.
I understand, but I'm saying, well, let's say the car was on Melbourne and you said you're standing outside this building. Would it know that there's a gate and you
Yeah.
can't go through it, or it would know that? I mean, I think it's open during the day, but I think, right? Well, at least at night it's closed. So it used to be open at night. I don't know why it's closed. I guess they're cut back to something. Anyhow, so feasibility is that we want to make sure that it's very expensive, right? Because technology, that's why we brought in the example of the Tesla, that it always takes more effort than we think it's going to. Right? Obviously, Tesla would be a lot happier if their self-driving feature was really self-driving, right? But it just takes time, right? They're not trying to, they're losing money when they, whoever, the first to come out with real self-driving like is going to be the winner. So everybody's in a rush to do it, but it takes a lot of time because it's new, right? And I think GM gave up self-driving technology, right? Or maybe Ford. I forgot which companies, they abandoned the whole idea. It was just too expensive, right? So feasibility is that you have to warn the person that this is development and development equals high costs. Okay. And you also you ask the person, can you afford that? And also, do I know as a developer, do I know how to do whatever they want me to do? Like I personally, like I said on Tuesday, I don't know how to do web programming. I mean, I know how to do a little bit, but I can't say, I went, someone wanted to, New York City wanted me, came to me, asked me to write website that'll handle, whatever. Yeah, I wouldn't be the one to ask because I don't have a lot of experience in that. I might be able to figure it out, but. So so you at both sides, both from the developer and from the client, we want to know that it's feasible. Okay. Next is design architecture requirements, which we got into, which is you challenge you don't you try not to assume too much because you want to find out really what you need to do. And then design architecture is basically before you code. Yeah, it's really, for me, it's really hard not to jump into the coding, but you should try to think about it a little bit, right? Think about how it's going to work, how, how it's going to be laid out. And actually, we have there's a chapter 6 or 8, I forgot which chapter deals with this, okay, with this issue. Um, so and also a lot of that's architecture, and then a lot of the actual writing of the code we're going to deal with even before that. Okay. In fact, hopefully we'll be able to look at that today. And then testing, we said was very important um, because you don't want it to crash. And then release and deployment are the same thing, just different fancy ways of saying it, which means you're giving out the software. And then documentation we spoke about is, in other words, this is actually sort of like depends on your company, who you work for. But like, for example, where I work, I'm very happy because we have very little documentation. So why am I happy about that? Well, usually it's a good thing. Right now, I happen to be working with something that deals with SharePoint, and I don't know, have no idea I'm trying to debug something without knowing exactly why it's not working. And but there's, I tried even using uh, Gemini, I think, and so far I haven't been able to come up with a reason why it works in one version with SharePoint, but doesn't in another version, and I can't see the difference. Like it's really, really driving me crazy. But the point is that the code is just basically, I could see the code. There's only like 5 lines of code per method, so the code is obvious. I just can't see why it's not working. So I don't think if it was documented, it would be easier for me to understand what's going on because um, as long as the code isn't like a bunch of if statements or crazy conditions, it's a straightforward pretty much. So it's easy to figure out, like you could just Google what does this object do and stuff like that. Like, or as long as it's clear. So I used to work though, when I first started programming, methods were very long. You could have a method that was 100 lines, 80 lines, you know, and then they would say you have to need like a whole paragraph before and explain what every input is, what every parameter does. Um, and then you would have every 5 lines of code, you have to give another comment. And the problem with that is that I see that in the code, but the problem is in where I work, problem is that this code was the comments that you could see are from like 10 years ago. In the date by it says that sometimes it says the date, or it's either it doesn't make any sense and I just delete it, or it was written so long ago, way when the code had some meaning and now has no meaning. So um, so the point is that, so what's the problem with documentation? Offhand, it sounds like a great idea, right? If someone writes up a whole novel about a whole book about how the function works and what the assumptions were, blah, 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 and then someone else has to work at it, they just open the book and read it, right? So it sounds like a good idea, right? And I always thought that where I work, we were just being lazy, right? But actually, I feel a little bit better now because I read that this Uncle Bob or Robert Martin, he explains why documentation is not such a good idea. He says, well, at least on that, like he says, minimize, meaning that like where I work, we do have documentation, but only where it's like where the person looking at the code says, "Huh? Why is the person doing this strange thing?" So then you explain, well, I'm doing this because of, you put like a one-line comment. I'm doing this because I couldn't get it to work the regular way. The regular way kept crashing. I don't know what. Yeah. Listen, so he says instead, because it's what's the main issue? So in a nutshell, what he says is because documentation is like it's something that refers to code, but the code is always changing, right? And the documentation is referring to that. So every time you change the code, right, what do you have to do? Update the documentation. But most people don't bother doing that. So basically, documentation becomes a waste of time. So he's saying that, so this idea of documenting everything you do would be a good idea if it was always kept up to date. But number one, but nowadays it's very, very rare that when something is changed, it's properly the documentation is updated. Um, I spoke to somebody who works he's an engineer for like a nuclear submarine company. Uh, he told me that they're really, really, everything is documented, like, because, you know, everything is tested in triplicate or whatever, because, nuclear submarine, you got to be really, really, really careful every time they make a change or whatever, any change that's made, even like the type of paint they use, I think has to be, they're very extremely careful, because like you're underwater, for example, you would think what difference does it make what paint you use, right? But he told me like if you're underwater, you're breathing in those fumes, right, for months. So everything has to be, or shaking, everything is shaking, so everything has to be thoroughly thought about before you make a change and thoroughly documented. So, but in general, most of us are not going to work for code for a nuclear submarine. So chances are that the documentation will just, like you come to a company, they'll say, "Oh, here's the documentation, read it." And you look at it and it's nothing, it was written by somebody 10 years ago and hasn't been updated since. And like you just it's waste of time, basically looking at documentation. So usually the only way to really know what the code does is really just to look at the code. So, um, so that's so I feel a little bit better where I work. We don't really have great documentation because the code itself, well-written code, like small methods and clear methods, are better than, unclear code and a lot of documentation, right? So if you make it simple that people could just look at it, especially nowadays where you have, you could easily click on a font method and see where it's used and see how it's used, right? So it's more important to be clear, the code to be clear than the documentation to be clear, right? It's better to have good code, and then you just, then you don't have to worry about, keep on updating documentation because no one's going to make sure. It's very rare that anybody looks like no one makes extra money at a company because, hey, I spent a month updating our documentation. Boss says, well, I'll give you a bonus. It doesn't happen, right? Right? They're not going to give you a bonus for great documentation, right? So no one, they want just, the boss just wants something that works. So they're not gonna, so documentation is usually something that falls, to the wayside. So that's why he says don't even bother doing it. It's just gonna waste your time. Um, okay. But again, do whatever your boss tells you. If he wants you to spend your day, documenting it, whatever they tell you. I'm not going to tell you not to do what your organization does. But I'm saying, but if you have a choice, then you should probably concentrate more on making the code very clear than worrying about comments. Okay. It shouldn't, there should be obvious what you're doing. It shouldn't be like a mystery. What is going on here? Like, right? If it is a mystery, then it's probably the code could be improved. Okay, next is finally 8, which our book calls Evolution, but we just call it maintenance or coming up with a new version, right? So basically, after you release it, and I'm not sure where documentation goes, even goes somewhere towards the end, and then you have evolution and maintenance, which means we go back to step 1 and start all over again, right? For a new version of the code. Okay. So I'm going to skip this and we left off over here with the buzzwords. Okay, so these are, I think we spoke a little bit about, I'll just go through these, okay? So performance means that, like a high performance car means like a car that runs fast. Exact same thing for a program. Performance means that the program runs quickly, there's no delay, right? High performance software is like in New York City, if you get a job at Wall Street, that's very important, right? That's a very anytime you're dealing with trading systems, like then you need time is really, performance is very, very important. Usability. So in other words, so basically in the first chapter, we're outlining number 1, what's involved in the software project. So you could see only one of the steps is the actual coding, but there's a lot of other things involved, right? So, and then the second part is we're going through what are the things that we look for in a good, in other words, what is our goal, right? What are we trying to produce when we produce software? So one aspect of chapter 1 is what are the steps that a software project entails? And the second thing is, what is our goal? What are we trying to produce? Like, what are things that say, oh, this is a good software, right? So one way is by looking at these qualities of or buzzwords, right? Which people, some are nowadays, I guess, AI would probably be a good buzzword, right? Whether or not it has any AI in it, you just say it has AI, whatever that means. Yeah. Since there's no one to challenge you saying, oh, it's stupid, it doesn't have AI. Yeah. You could say, yeah, now everything is AI, right? Zoom has AI, everybody has AI. So, um, Uh, though someone told me that. Uh, oh, okay, let's go. So performance is one of the software qualities. Speed, usability, meaning that the code is UX, UI UX stands for user interface, user experience, right? So that's another good quality of software. That's another thing we look for is that it's easy to use, whoever the intended audience is. And then reliability is that it's reliable, meaning we can rely on it. Functionality, we mentioned, I think we're up to here, is that the code is functionality is actually divided to 2 parts. One is what the actual requirements are. Like requirements actually have 2 parts. There's actually functional requirements, and non-functional requirements. So functionality is basically what they ask for, right? Because when the user writes up a contract, they'll say, we need it to do this, this, and that, right? And non-functional requirements are those type of requirements which sort of underlie all those functional requirements. So, for example, very simply, let's say someone asks you to write a website for them, right? So that would be the functional requirement to create the website. The non-functional would be it should be secure. They never said a word about being secure, right? So why does it have to be secure? Because that is the non-functional requirement. Because nowadays every website is secure, right? You probably never even heard of a non-secure website, right? So every website you go to is HTTPS, right? It's in fact you even used to like have a where does it say the security somewhere around here, right? Uh, Somewhere here it is. See, here it says it's secure. But it used to be, they used to they don't even bother anymore to show you that secure website. It used to be they would show you if you remember a couple years ago, they would show you like a lock, right? To show you it's safe and warn you if it's not safe. Now they won't even, I don't think they'll even allow you to see a unsecure website, right? Something that doesn't have a secure and all this stuff, right? So, um, so that's assumed, right? So if someone asks, and the same idea is a trading system, um, let's say you're writing something that um, that like medical records, right? They don't have to tell you that it has to follow HIPAA regulations because those are the regulations. So it's assumed that you're going to store the data in HIPAA compliant manner, right? You're going to encrypt whatever you have to encrypt and all that. Yeah.
Well, thing like maybe functionality will be like, let's say if someone is asking me to make a website, like let's say the quiz college website. So I thought like maybe functionality like the requirement would be they could view their name, GPA, and then functionality would be like they cannot change their GPA. Is the
No, non-function, no, that's the thing that the user could see, but the non-function would be like things that are okay. So no, the way you could tell something's non-functional is if it's number one encompasses more than a specific requirement. Means it's like it's more broad than one requirement. It's like basically if your system doesn't have this, then your system is unusable. Meaning like if you have a system which is really nice, but it's not secure, then or it doesn't store, say, medical system that's not HIPAA compliant, so it's not unusable, right? Even if it's a beautiful system and easy to use, everything else, but if it doesn't have that non-functional requirement of being HIPAA compliant, right? HIPAA, like following the way the records need to be, personal data needs to be stored, especially medical records, right? If you don't have that, then the program is useless. If you have a trading system which is really great, it does everything you need it to do, but it takes a minute longer than the competitor, no one's going to use it, right? So certain things are not just one specific thing, but the whole involves it's very broad. It encompasses more than one requirement, and also sometimes it's also not even spoken about, meaning that it's so obvious that a lot of times, no, it's people don't always say everything about, you can't say everything, you can't specify everything, because if you specify everything, then the requirements would be a million, you can't say what must means, you can't like include like there has to be, there's a limit what could be going to a requirement. Like if I say, um, like I need your paper in tomorrow, I don't have to explain, what does tomorrow mean? Like, I mean, I guess you could say, well, what time do you mean? I'm just thinking, yeah, but in general, like you could you could always make things add more detail, right? There's a limit how much detail. So the stuff that's not explicit would be the non-functional part. Okay? In other words, usually that would be something major. Something like, oh, it has to work on let's say you agree somebody to create a web server, so then it probably, unless it says otherwise, it has to like probably run on a Unix server because, right, aren't most web servers Unix servers, I think, right? So if no one said anything about it, then probably the non-functional requirement would be has to run on a Unix server, whatever, the standard web servers. I think, right, nearly all of them are, all websites run on Unix servers or Linux, I'm not sure, but they're not on Windows servers, right? They're too expensive. So actually we could ask Google that. But that's the idea. In other words, if someone asks if you agree to write it, but they left it out, like the non-function would be it has to run on on that type of whatever the common server is. Right. Okay. I just see what is I'm pretty sure the most common type of server for a web server. I think it is Unix or Linux. Oh, Apache. Uh, uh, there definitely is not true. Oh, here we are. Linux. No, they don't use Windows Server. Come on. No, this is old. I don't know where they found this, but they don't use Windows. That's very, if you look for, I remember like at one time I was trying to create a website, and I remember like you had to pay a lot more money to get Microsoft Server. It was a lot cheaper, right? To get like a lot of places would give you like a free Unix server, right, or something they'll run on. But I remember Microsoft cost a lot more, and also IAS is not, I don't think it's common. Um, oh, so it says Apache, whatever it is. But if you're writing a web server, then and then nothing is specified in the requirements, it would probably be whatever shows up in that search, right? Whatever the most common one is. Okay, and I don't think it's Microsoft. It would probably be something Unix based. Um, and the same idea with the database, right? Because most databases are Unix based, like SQL Server, Microsoft SQL Server is not the default, right? MySQL is probably, right? Okay, maintainability means that we always like code which is easy to fix, which means number one, what we spoke before, clean code and comments, right? So okay. And we'll get into that. What does that mean to have clean code? By the way, he wrote a book called Uncle Bob. He wrote a book called Clean Code, I think, Clean Coding. Uncle Bob, uh, Clean Coding. I think he has a book like that, or I might have it. Uh, Clean Code. Yeah. So he wrote a book about that, how to write nice code. So this is Uncle Bob, Robert Martin. That's what he looks like. Did he show you the picture of him? Here he is. That's Uncle Bob. I believe he's still active. Yeah. But a lot of this course is based on him. So um, I like his ideas um, and some of the the standard ideas that we do nowadays are based on his ideas. Okay. Um, Security. Security means to protect code, right? As opposed to safety, which means safety, meaning that security is like like think of a fence around something, right? So we want to keep outsiders out, uh, or or we want to keep our messages safe, protected. And safety is actual safety, meaning that, like, if you write software, make sure it doesn't harm people, right? Like if you write medical software that control, let's say, heart pacemaker, make sure it doesn't give some, doesn't kill somebody by accident, or you have software that drives a car, make sure it doesn't crash, right? Or a software that's inside the uh, whatever, some part of the car, make sure it doesn't malfunction and cause an accident, right? Okay, different types of software. This is like the very end of the book, chapter one. Um, basically, he describes another way of looking at the software besides having these qualities, which they're all good to have, is like how do you categorize software? So that's a quick way of doing it. I just copied from the book, I think. Um, it's been a while since I looked at the book, but I'm pretty sure. Uh, I think he actually has more categories, and I just made it smaller. So standalone software is basically software that's self-running, like software that runs on the refrigerator. It doesn't need any network to get updated. Transaction-based software is software that does everybody know from databases what a transaction is? What's it
Like
like?
any banking,
What's a transaction? Yeah, in databases, like, like SQL stands for no, structured query language. Uh,
any queries we are doing,
what?
queries that we are doing to the database, that's called a transaction.
Well, it depends on your database, but so basically, a transaction means that that either everything fails, or no, you don't have, you never have like only some of the data, right? So no, it's basically where you need accurate data. You don't want like somebody started typing in their name, the first and last name, and only the first name got saved and not the last name, right? That would be no good, right? Because then you don't know what state you're in, right? You don't know what's accurate. Was it supposed? Did they not have a last name, right? So you never want to have. It's always better to either all succeed or all to fail. You don't want in between. So that's what transaction means. It's all together. You don't want, so for data, you need transaction-based software, right? You don't want to like someone's editing an image in Paint and or you editing a Word document, you don't want like, while it's saving the file, if something goes wrong, someone pulled the plug from the machine or whatever that caused the computer to crash, you don't want it to have half of a file, right? Because then what good is that? You either want the previous version or you want the current version. You don't want something that's neither, right? So usually like most software, like Word will probably, when you save a file, first it probably writes to a temporary file, and then only after that's succeeded, it renames probably or deletes the old version with the new, or something like that, right? So that's how. But the idea is that you don't want to be left with like half of a file, right? Because what good is that going to do you, right? You'll want either everything is saved or nothing is saved. You don't want something where it crashed in the middle. Um, Embedded software would be software that what makes it special is that it's basically low-level software. It's usually controlling like devices. So what's special about embedded software is, besides the fact that it's low level, and most of us would probably never work with that type of software, except if you work for like Tesla or some type of, you know, uh, uh, it's not that common to find in the business world somebody who writes software for hardware. But basically you're writing to chips, you're dealing with CPUs and stuff like that, with registers and all that. So number one, it's very low level, like assembly language type of thing. And number two is that again, I don't know a whole lot about this because I've done a little bit work with hardware, but not a ton of it. And but apparently if it's embedded, it's like built into it comes like with them, like you get a microwave, the software is there. So if you would change the way the microwave would work, you would have to maybe change the chip also or modify the chip. So there's that that dependency or that relationship between the software and the hardware, where changing one changing the software might be very expensive because it makes you might have to change the hardware, or vice versa. If you change the hardware, the software might have to. Well, probably that for sure would have to happen. So that type of programming is more very, very delicate. Yeah.
So embedded software is like, oh, like microwave, vacuum.
Yeah.
all those kind of
Right.
stuff.
Right.
The BIOS and the motherboard technically embedded.
It used to be, right? But now I used to think that BIOS was a embedded, but now I see they're updating it, so I'm not sure if it's built in or I don't know, right? Sometimes I get my computer says updating BIOS, so I don't know how that works.
Or you upgrade the BIOS, the bricks, the motherboard, it stops working.
Yeah, it tells you not to turn it off. Right. Yeah, I used to have that with Windows updates where, probably still with Windows updates, it would, if it says don't turn off the computer while updating. Right. I think they might have gotten a little better with that. Yeah, I remember like I started updating it and then it was taking forever and I had to leave. So I didn't know what to do. So I turned off my computer because I had to take with me. And yeah, whatever was the best. So yeah. So I remember I was like walking across the street with my laptop. I kept it open. And I was afraid to close it because yeah, I didn't want it to crash. Um, And then there's web software, which is basically, oh, what's unique about that is it's always has a specific architecture and also its specific issues because by definition, web software is, you always have two parts, right? You have the browser, like over here, you have the browser, and then you have the server, which is another machine. So you're always going to have two 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 parts speaking to each other, communicating, right? You have the server somewhere else, and the client requesting or sending information to the server, right? Um, and then we have a game software, which the most important things is graphics, right, and speed, and financial software, which we said always has to be accurate, right? And sometimes if it's like for a trading system, speed is also important, right? So you need both, right? You can't be missing money. Yeah, can't have a person get put $100 into their account and then there's only $99 a month later. Like what happened to their money, right? So it's very difficult, right, to do that because like sometimes they invest in different things and or like when you do math operations, you have a remainder. So what do you do with that remainder? You don't want the bank to lose money or you don't want the client to use money. So you have to like think about it. It's not so simple, right? Right? Like if they have, let's say, they get say a 3% interest rate and you do it every month or whatever, then you'll come up with fractions of pennies. So you got to figure out how you want it to do, how you want that to work. Right. There's one guy who worked at a bank and what he did was, or she did, I don't know, I forgot who it was, that every time there's a fraction of a penny, he or she would send it to their own account. And eventually, over millions of transactions, you get a lot of money, right? So, yeah, so that was a pretty creative way of doing things. So people were losing, no one noticed they're losing fractions of a penny. Yeah. So anyhow, so that'll be it for today. I was going to start something else, but we'll start on next Tuesday, object-oriented programming. Work on those presentations, people, please, and keep in touch. Send me emails, okay? And be safe and have a warm weekend if you can. It's going to be kind of cold. Okay, stay warm. Okay, good night.
Those presentations, they're just like self-research.
Yeah, yeah, yeah. Basically, don't worry, no one's ever gotten less, very rare that someone's gotten less than an 85 on a presentation, and normally it's like a 95, your normal grade. So you should be very excited especially the first people I would give good grades because they're the first, yeah, so.
There is time limitation on for the presentation, like I mean minimum time
Say again?
for the presentation.
You
like,
mean when's the last date?
no, the length of the presentation?
5 minutes, right around that document, 5 minutes.
If it goes beyond five.
No, I'm not gonna penalize you, but
I mean, if
pl-
it goes beyond, I mean, it's I don't know, but I don't know, I feel like it.
no, I'm just no, no, I'm not like, standing there with a stopwatch and, measuring. Yeah, it's fine if you go over a minute, or two, but I'm saying, try to be considerate, yeah.
Alright, good.
Oh, you also forgot to mention the presentations, I put on the midterm and the final, I put questions from them on the midterm and final, right? Usually I do,
From Chair's presentation,
yeah, before, when I write the midterm, I always do like a new midterm and final each semester, so when I write the midterm, I always include questions from the presentation, so, yeah, so you should listen to your colleagues. Okay, yeah. Not difficult, but just see if you're listening. Okay. Good night.
and Professor, I